In this video, we're talking about the inverse of a square matrix. So the identity matrix is a square matrix of order n with ones along the main diagonal and zeros everywhere else. So in other words, RREF. I have shown the 2 by 2 and the 3 by 3 identity matrix. So we also know that we take a matrix A and multiply by the identity, we get that A matrix. Well, how do I solve for I? Well, I can take the inverse of A from both sides, and if I can show that A times A inverse and A inverse times A equals the identity matrix, then I know that these two matrices are inverses of each other. All right, so let's see if these two 2 by 2 matrices are inverses of each other. Well, only way I'm going to be able to tell for this is to actually do the multiplication. So let's do that. All right, so let's start here. So that's 9 minus 8. We've got negative 4 plus 4. Here we've got 18 minus 18. And here we have negative 8 plus 9. Simplify. And that does give us the identity matrix for a 2 by 2. But we're not done yet. I must now multiply the matrices in the other direction to make sure that they're inverses. So here again, we've got 9 minus 8. Here we have 36 minus 36. Negative 2 plus 2. And we've got negative 8 plus 9. So simplify. And again, we have the 2 by 2 identity matrix. So we know then they are inverses. Since, and we can write this very, very quickly. If I scroll down. Okay. And it really doesn't matter what is matrix A and what is its inverse. When we multiply them together, either direction, we get back to the identity matrix. Okay, so let's talk terminology briefly. Non-singular is a matrix that has an inverse. Singular, a matrix that does not have an inverse. So the only types of matrices that are going to have an inverse are square matrices, but not every square matrix has an inverse. To determine the inverse of a square matrix, we're going to form the augmented matrix A, and I of n where that is the identity matrix. We're going to perform row operations to this matrix, okay, to get the identity on the left-hand side and then a new matrix B on the right. Well, that B is going to represent the inverse of matrix A. And we're going to use Gauss-Jordan elimination to get the matrix in RREF. And then we're going to verify our answer. Okay, so now let's determine what the inverse for this matrix is going to be. All right, so I'm going to write underneath. And then right next to it the 2 by 2. Now, I am going to take row 2 and add it to row 1, and that's going to be my new row 1. Okay. So I'm going to do this row operation here. So let's put that here. And again, row 1 is changed. Row 2, we remain the same. Okay. Now, it's a negative 1 instead of a positive 1 in the left corner, so I'm going to take the opposite of R1 and make that my new row 1. So I will put this below. And again, row 2 remains exactly the same. Okay. So now I need to make this negative 4 a 0. So I'm going to take row 1, multiply it by 4, and add it to row 2. And that's going to be my new row 2. Okay. All right, so let's do the row operation here. And we'll put this here. So again, row 1 remains the same. Change row 2. Okay. Now, so the first column is done. So now this -2 needs to be a +1. So I'm going to multiply the entire second row by -1/2. Okay. And we'll put this matrix below. So again, row 1 stays the same. Okay. Okay, now this -1 needs to be a 0. So here I can take row 2 and add it to row 1, and that's going to be my new row 1. Okay. So I think we can add these in our head without writing it out. So we'll take 0 plus 1. We'll take 1 plus -1. We'll take 2 plus a -1. And we'll take 3/2 plus a -1, which is 1/2. And we leave row 2 alone. Okay. So it is now in RREF form. So according to this, our inverse for this is this 2 by 2 matrix. Okay. Now, it is important to double check your answer for this. So I have done the work already below to show that A times A inverse and A inverse times A both equal the 2 by 2 identity matrix. So I'm very happy with what the solution is for this. All right, so let's now do this with the 3 by 3 matrix. So again, first thing I'll do is I'll write this out. Now put the 3 by 3 identity matrix. Okay. And remember, we're going to get into Gauss-Jordan form. Okay. So what am I going to do? I'm going to take what? R1 plus R2 is my new R2. And we're going to take -2 times R1 plus R3. And that's going to be my new row 3. Okay. Okay, so here I'll do R1 plus R2. Well, that's 1 plus -1, that's 0. And we've got 1 plus 0. And we've got 0 plus 1. We've got 1 plus 0. We've got 0 plus 1. And we've got 0 plus 0. Okay. Now, let's do -2R1 plus R3 is our new row 3. Okay. So -2 times 1 plus 2. -2 times 1 plus 0. -2 times 0 plus a -1. -2 times 1 plus 0. -2 times 0 plus 0. And -2 times 0 plus 1. Okay. Okay, so underneath then I will rewrite. Okay. Now keep in mind row 1 stays the same. Okay. Row 2 has changed. Okay. And row 3. Okay. Okay. Now, the first column is done for us. So now the 1 is in the where it belongs in the second column, but this 1 needs to be a 0, and that -2 needs to be a 0. So what am I going to do? I'm going to take -R2 plus R1. That's going to be my new row 1. And I'm going to take what? 2 times row 2 and add it to row 3, and that's going to be my new row 3. Okay. Okay, so let's do each of these on the side here. Okay. So again, we've got what? -0 plus 1. We've got -1 plus 1. We've got -1 plus 0. We've got -1 plus 1. -1 plus 0. And -0 plus 0. Okay. Now, let's do 2R2 plus R3 is my new row 3. So 2 times 0 plus 0. 2 times 1 plus a -2. 2 times 1 plus a negative 1, 2 times 1 plus a negative 2, 2 times 1 plus 0, and 2 times 0 plus 1. Okay? All right, so now I'm going to write my new matrix below. Okay, okay, so my new row 1, row 2 stays the same, and my new row 3. Now, column 2 is done. So now let's take a look at column 3. 1 is where it belongs, that's great, but this one needs to be a 0, and this negative 1 needs to be 0. So using row 3, I'm going to take the opposite of row 3 plus row 2 is going to be my new row 2. And for row 1, I'm going to take R3 plus R1 is going to be my new row 1. Okay, so let's do this on the side then. Okay, so it would be row 3 plus row 1. Okay. Now, let's take the opposite of R3 plus R2 is my new R2. I'm going to change that to blue. Okay. Okay. Okay, so now I'm going to rewrite this matrix again. Okay, so put in my new row 1, my new row 2, right, and then row 3 remains the same. Okay, so according to this then, B inverse then is going to be this 3 by 3 matrix. Okay. Now, similarly to what I did for the previous problem, I have done the work ahead of time to show that B times B inverse equaled the 3 by 3 identity matrix, and B inverse times B also equals the 3 by 3 identity matrix.